Welcome to Appliance Tech tutorial. On this tutorial, we'll be doing these loops. We will be applying Kirchhoff's law of current and voltage to calculate the unknown currents. So we will start with this one, then this one, and this one. So let's not waste time. Let us start. So on this loop, we've got on this circuit, we've got two loops. So loop number one and loop number two. It doesn't matter which one you call loop number one. This one can also be loop number one, and this one and be loop number two. So what do we know here is the total voltage if we are to start on this loop, which is let's call this loop 1, which is A, B, C, D, A. A, B, C, D, A. So what they like to ask if you are doing N3 is that find the equation for this loop. Then they will say find the equation for this loop after that. And after that, they will say calculate the unknown currents. So on this video, I will be helping you on how to develop the equation for this loop and this loop, then later would calculate I1 and I2. So on loop 1, which is loop A, B, C, D, A, what we know is the total voltage. So our voltage is 10 volts. Okay, so let's just write 10. What else do we know? We know that okay, this is like this. If I were to take this loop and draw it here, it's like this, so that someone would not get confused. That's the 20 ohm resistor, and that's our battery. It doesn't matter if we draw it like this. So we've got this, so we've got a point there, we've got a point there. So this is like this, that is 15, and that is 5. So this loop is just like this. So what do we know if we have a junction there and junction there, or a point there? We know that from here to here we are parallel to here. So this resistor is parallel to these two resistors. So these two resistors are in series. So what do we know about the series resistors is that if we want the total of these series resistors, we just add 15 and 5. So R series is equal to 20 ohms. So now this circuit has changed. It's like this now. We've got the 25 resistor, we've got the battery. What else do we have? We now have the 20 ohm resistor. So now this circuit is like this. So what do we know about the volt drops across here, we know that if we add the volt drop here and here, it should be equal to the total voltage. So we would say Vt, let's come back here so that you know what I will do beneath comes from. So is equal to the voltage across the 25 resistor plus the voltage across, we're not gonna say 15, we're just gonna take that resistor and say the voltage across the 20 ohm resistor. So now Vt is total is 10 volts, and what do we know about the voltage across the 25 ohm resistor? It's gonna be I1, which is the current, times this resistor, which is 25, plus, now we're coming across this resistor. What is the current across this resistor? It said it's I2, so we'd say I2 times 20 ohm resistor. If you want to, before this step, you may say 10 is equal to I1 times that resistor R25 plus I2 times R20. So after this step, you will then take this and write it here and say, so I jumped this step, so let us write this as it is. So 25 plus I2 times 20. Now what's left for us is to simplify this. I2, so 25 will come this side. Sorry, that's I1, not I2. And plus 20 over I2. So this one would be our first equation, equation 1. Now let us go to this loop and get an equation for that loop. Again, what do you see on this loop? I think you see that on this loop, this resistor and this one, they are in series. So if we add them, we'll get 30, and that 30 ohm resistor, it's in parallel with 25. So what we just did here, it's what you will also do here. Now let us show which loop we are dealing with now. It's A, D, E, F, A. A, D, E, F, A. So we then know again that Vt will be equal to the voltage across this 30 ohm resistor plus the voltage across. It doesn't matter which one you start with, because we are only adding here and the voltage across this 25 ohm resistor. If you want to, you can put ohms here. With me, it doesn't matter. So the total voltage, this loop is connected across this voltage. So let's say this voltage was not in the middle, was here. What are we gonna do with on this loop? We're gonna say Vt is equal to 0, because this loop has no cell connected across it. So Vt, what is Vt? We know that is 10. Then across, we know that it's gonna be R30 times what is the current across R30. Now the current across R30 is now I1 minus I2. And what is the current across I25? It's gonna be I1 times R25. So now our 10 is equal to R30 is that 30 ohms that we know, I1 minus I2 plus I1, what is R5? Is R25, sorry, it's 25. So this is what we get here, 30 times I1, it's 30 I1 minus 30 I2 plus 25 I1. So we've got I1 and I1. So if we add these, we get 55. So 10 is equal to 55 I1 minus 30 I2. So this is our second equation. So now for us to be able to get these currents, we need to make I1 stand alone. Like by that, we need to transpose I2 this side, then divide everywhere by 25. Okay, let's do this. That is 10. Okay, if we want to take this one this side, this is what we do. This is basic maths. So we'll say plus 20 I2. So we would minus 20 I2 this side. What we do on the right hand side, we do also on the left hand side. So we would say minus 20 I2 also on this side. This one is positive. So these will cancel. So here we'll be left with 25 I1. Remember, we want I1 to stand alone. So that means we must divide by 25 and also divide this side by 25. So I1 is equal to, now we can make I1 stand alone like this. So we know that 25 divides here and divides there. So we would say minus 20 I2 divided by 25 and plus 10 divided by 25. So now we can take I1 and substitute I1 there. So let's do that. But before that, I like to simplify this. Like here we know that we have 5. How many times 5 goes to 10? 2 times. And 5 goes to 25? 5 times. And 5 goes to 25? 5 times to 20? 4 times. So that means I1 is the same as minus 4I2 divided by 5 plus 2 over 5. Now we can take this I1, sorry, I like to say it's I2. We can take this I1 and substitute here to get I2. Let's do that. This is gonna be 55 into minus 4i2 and or divided by 5 plus 2 divided by 5. So we would close the brackets and say minus 30 i2. We know that this is the same as 55 minus 4i2 plus 2 all divided by 5. Hope you agree with me on this. If you remember your math, minus 30i2. So how many times does 5 goes to 5? 1. How many times does 5 goes to 55? It's 11 times. So this is the same as saying 11 times 4. 11 times 4, we get 44 i2. And how many times does 11 go? Oh, we say again 11 times 2, that's 22, minus, remember, we have 10 here, 10, 10. So this is gonna be minus 30 i2. So 44 minus 30, it's 14 i2. So we take this to this side, this 22, I forgot something. You see, when we multiply the 11 times 4, we're supposed to be having minus 44. Yes. And this one too is supposed to be minus 20. No, this one is supposed to be positive 22. So here what is gonna happen is we're not gonna minus, we'll add. 44 plus 30 is equal to minus 74 i2. So we take this 22 to this side and this 22 becomes negative. So we say negative 22 plus 10, that gives us minus 12. So now if we want i2, what do? We divide by 74 by minus 74 every side. So what is 12 divided by 74? 12 divided by 74 is 0, and remember it's minus minus, then the answer will be positive. It's gonna be 0, 162 amperes. So that is I2. So if we want to know I1, we would take this and substitute it here. So let's do that here because I don't want to use another paper. So we know that I1 is equal to minus 4 over 5 I2 plus 2 over 5, right? So this is gonna be minus 4 over 5 multiplied by 0, 162 plus 2 over 5. So this one multiplies there. So 4 times 0,162 is gonna be, it's gonna be 0,6, it's gonna be minus 0,648 divided by 5 plus 2 over 5. So now let's divide, let's just get the answer here. If you're using this calculator, this is what you would do. Then you would say minus 0,648, and you would put 5 here, and then you would say plus, you then put 2, and you then put 5. You get the answer. The answer is not negative, is positive. So our answer is 0,2704. If you want to, you just write it out. So they will tell you how you should round off. So that is our I1. So we did got I1 and we did got I2. So we did good. Something happened that I didn't expect while we're doing this one. This circuit took us long. So I'm definitely sure that this one will also took us long. I don't know how long. So I'm gonna make part 2 for this one. If we happen to finish this one before 10 minutes, I think we will do this one in the same video in that one. But if it becomes long again, then I will have to make 4 videos for these loops. So that means we'll have part 1, part 2, part 3, part 4, or part 3 and part 4. We will see as we go. Please like the video, comment on the video if you want to. Please share the video so that others will also get the knowledge or information that you got on this video. Thank you.